Hi there, I'm Steve Reynolds, President's Professor in the School of Earth and Space Exploration at Arizona State University. I'd like to welcome you to one of our virtual field trips funded by McGraw-Hill Education. This time we're on the north rim of the Grand Canyon. The north rim and the south rim are pretty different in a lot of ways. For one, the north rim is about 1,200 feet higher in elevation, so it gets more rainfall, has different kinds of vegetation than the south rim. The other thing is the river is much farther from the north rim than it is from the south rim. The south rim, you're sitting up there and the river's right below you. Here, the topography gradually rises like that, and so on the north rim you're here. So there's a big distance between the two. And the other thing is that it affects the way that the rocks erode, because the rocks are tilted very gently from the north rim to the south rim. And so on this rim, it's eroding down this way, whereas the south rim, it's got an escarpment and it's eroding that way. We're at Cape Royale, and it's a nice place to look at the stratigraphy. In the Grand Canyon, there are these different packages of rock. The lowest package is a series of metamorphic and granitic rocks that we call the crystalline basement. It's about 1.7 to 1.75 billion years old. And then on top of that, there's some tilted rocks called the Grand Canyon Supergroup. And we don't see those very well here, but we'll see those from other places. And then on top of that sequence is all the Paleozoic rocks, which in here are pretty much flat lying. That's the main thing you see in this view from Cape Royale. From this location, we'll concentrate on the Paleozoic rocks. The lowest Paleozoic unit is that lower flat-lying ledge. It's a resistant sandstone called the Tepete sandstone. It's Cambrian. It represents the time when the seas first came in, and so you deposited a shoreline facies along the edge of the sea. So it's beach deposits and things that typically form along a shoreline. On top of that is a slope, which is the Bright Angel Shale or Bright Angel Formation, depending on your usage. And it represents muds that were deposited when the seas had moved a little farther inland, and so you were not right at the beach anymore, but you were now getting offshore muds. On top of that is a series of low kind of greenish ledges, and that's called the Muav limestone. And that represents a time when the seas were even farther inland, and so you started to get almost clear water, and so you get marine organisms that can grow and deposit limestone. Those three units, the Tepetes, the Bright Angel, and the Muav, are a classic transgressive sequence. As the sea's moving in, you deposit those three facies, those three different kinds of rocks, in different places at different times. Above the Muav is another unit that's discontinuously exposed in this part of the canyon. It's the Temple Butte Formation. It's Devonian in age, and it's mostly filling channels. And so where you had a channel, you'd preserve those rocks, and when you're in the upland adjacent to the channel, that rock either didn't get deposited or got eroded away. In this area, you don't really see it. You see it up some of the side canyons, but it's pretty invisible from the rim. With the Temple Butte being Devonian and the underlying Muav being Cambrian, it tells you that there's a lot of missing time in here. The Ordovician's missing and the Silurian's missing. There's no rocks representing those two periods of geologic time. So the contact between the Muav and overlying rocks is an erosion surface, where the erosion surface is basically parallel to the layers. We call that a disconformity. It's a type of unconformity. And locally, it looks more like an unconformity where it's in these channels, but in a lot of cases, it just looks like a fairly planar contact, but you can tell that it wasn't continuous deposition during that time. Above the Temple Butte is the big cliff looks mostly kind of gray, except it's got a red stain over it. That's the Redwall limestone. It's Mississippian in age. And it's a gray limestone where you're down by the river and there's nothing red kind of washing over it. It's just a gray limestone. But it's got the red rocks of the Supai sitting on top of it. And so that red material, the iron oxides, wash down the face of the Redwall and give it its kind of red color, and hence its name Redwall. It's Mississippian in age. It was deposited at a time when Arizona was very close to the equator. The Redwall was deposited in a tropical environment. We were by the equator, and so there's coral and all kinds of, clear water, warm water, tropical kinds of creatures. When the seas pulled out, you had a limestone surface exposed to all the tropical weathering. And so as a result, you had a major karst event where you have dissolution, you make sinkholes, you make caves, and you dissolve the upper part of the limestone and leave kind of a residual reddish soil that we call terra rosa. So the top of the red wall, when you walk along it, it's a very nice karst surface. It's also the event that caused the red wall to have a number of caves, not very visible from here, but in lots of parts of the canyon, the red wall's got all these caves, and then those caves collapsed, and as the roof collapsed, it kind of ate its way up to the surface to make some sinkholes. And so up on this top surface, the Kaibab Plateau, you have lots of sinkholes that are related to collapse of caves in the red wall limestone. There's some other units in here. There's a unit called the Surprise Canyon that we can't see, so I'm not going to talk about it, except I did. On top of that are all the red and kind of tan-colored ledges of the Supai group. It's a Pennsylvanian and Permian rock. It was deposited during a time when the seas were going in and out, and so you deposited sandstones and then mudstones and then sandstones and mudstones, occasionally a little bit of limestone in here, a little bit of conglomerate here and there. And so, but that's kind of this really obviously ledgy unit. The reason it has the ledges is it's reflecting the rise and the fall of sea level as glaciers were melting or forming. And so as the glaciers formed, sea level went down and you deposited one kind of rock. The glaciers melted, sea level came back up, and you deposit another kind of rock. So it's a very rhythmic section. That's really common in rocks of Pennsylvanian age in the Southwest. They reflect glaciation in Gondwana, not anywhere near here. But it was expressed by the alternating of slopes and ledges in the Supai. Above the Supai is a unit that's normally covered by light-colored debris coming from the overlying tan sandstone. That unit is the Hermit Formation, or Hermit Shale, and it's a bunch of siltstones, and it has really famous plant horizons in it that have been studied. But it's a slope-forming rock, and so if you've got any of the more resistant rocks sitting on top of it, commonly the Hermit has eroded back, and you've armored that slope with a whole bunch of blocks, debris from the overlying rocks. From here you can see there are a couple famous buttes, and you see a little bit of Hermit poking out where it's away from the buttes itself, but when you're on the flanks of the butte, it's mostly covered with the tan pieces from the overlying rock. The next layer up is this cliff of tan sandstone. It's called the Coconino Sandstone. It's the dominant thing that keeps you from going into the canyon where you want. It forms this big cliff, and so all the trails into the canyon are places where the Coconino has been broken up like along faults that makes it easier to get past it. The Coconino is inherently inside a tan sandstone, but you can see on these surfaces it has browns and reds, and some of that is what I call a natural stain. It's material that's leached out of the overlying rocks, and kind of the water carries it down the cliff face and it redeposits that, things like iron oxides and manganese oxides. Some of the other dark colors is something that we call desert varnish or rock varnish, and that's mostly from wind-blown material, and you have to have a rock cliff or rock face that's stable for a long time in order to accumulate desert varnish. So how desert varnished a cliff face is tells you something about how long that rock face has sat there. The Coconino has a whole series of beautiful crossbeds. From this perspective, they would be like this. They're not very visible here, but they're all through the canyon. And those are crossbeds are something formed by currents, either wind or water. And in this case, they're formed by wind, and they have this beautiful curved shape, and they're big. That type of crossbed almost always tells you that that was deposited by the wind. And so the Coconino is interpreted by everybody who studies it, nearly everybody, to be basically a deposit of an old sand sea, a whole series of big crossbeds formed by big sand dunes that were tens of meters high. Above the Coconino, there are two units which a lot of us structural geologists kind of group together. There's the Toroweap Formation, which is this lower one that has some kind of reddish units in it. It's a little bit, has some slopes in it, and that's also Permian in age. And then capping the Paleozoic section in here is the Kaibab Formation, and used to be called the Kaibab limestone. And it's got these beautiful kind of tan, brown, locally a little bit of yellowish ledges and cliffs in here. It's a very nicely bedded rock. And it's another marine rock. It's got beautiful fossils. It's got brachiopods and crinoids and bryozoans, things like that, and sponges. And so that was deposited again at a time when this part of Arizona was at the equator. One of the interesting things about the Grand Canyon story is you deposited limestones 3 times. You deposited in the Moave, you deposited in the Redwall, and then you deposited in the Kaibab. At each of those times, Arizona was close to the equator. So Arizona would migrate a little bit farther north, and then you'd deposit something else besides these nice limestones, and then we'd get back into tropical environments, clear water, warm water, and you'd deposit limestones. And so each one of those limestones represents a time when Arizona was at the equator. So I'm standing on the Kaibab Plateau, and I'm standing on the top of the Kaibab limestone, Kaibab Formation, and when you look at these rocks we're standing on, they have marine fossils in them. And so if you think of the history of what these rocks had to go through, they had to be deposited at sea level, and then they got buried by a whole bunch of other stuff. There are a ton of rocks that were sitting on top of this that formed the Painted Desert and the Vermilion Cliffs and places like that. There were a lot of rocks on top of here. So you had those rocks, and then at some point this whole land has to be uplifted. You had to erode all of those rocks off, and now you bring these rocks that were deposited in marine waters at sea level up here to 8,000 feet. So let's talk a little bit about how a canyon like this forms. First of all, this canyon is carved by the Colorado River, which you can see the canyon of it way off in the distance. And so the river erodes down through the rocks, and that's what controls the depth of the canyon, is how deep the Colorado River can cut at any point. And then once you've got that, you've got these big walls next to it, and gravity and other streams and rock falls and a variety of things kind of widen that canyon wall to make the width of this canyon in here. Cape Royale, where we are, is the shortest distance between the north rim and the south rim. And so that's one of the reasons why we're here. And but the same processes are happening on both rims. It's all gravity. We're up at high elevation, so these rocks freeze, and so you get water in the cracks, and it peels off rocks, and they fall down the walls. So it's gravity, it's weathering, it's a variety of things. Some stream action in here. Wind's not very important in here for a lot of reasons. One is there's a lot of vegetation, so you're not blowing a lot of dust around here, a lot of sand, and also there's a lot of vegetation cover, and it just makes wind less effective. Wind, in my opinion, is totally oversold as being really important in sculpting landscape. It does it. There are places it's important. This is not one of them. One of the important aspects of the Grand Canyon is the way the fractures control the landscape. This is a nice view from Cape Royale looking south. And what you can see is a nice big cliff of Coconino sandstone. It's got a whole series of vertical joints in it. That's the typical joint orientation throughout the canyon. Actually, the typical joint orientation most places on Earth. And what you can see is that the fractures actually kind of carve up the cliff and give it some texture. If there are no fractures, it just ends up being a really smooth cliff. One of the things you can see here is the difference between the spacing of the fractures in the Coconino versus the underlying red rocks of the Supai. In the Coconino, they're a couple meters apart, the fractures. And if you look in the underlying Supai, the little sandstone ledges that are protruding out from the hillside, they have fractures, but they're more closely spaced. And the reason for that is that the spacing of fractures, specifically these kinds of fractures, which we call joints, is largely controlled by the thickness of the unit. So in this case, you have a thick, pretty homogeneous unit in the Coconino, and it gets pretty wide fractures. And when you go into the Supai, you have thinner sandstones, and so therefore more closely spaced fractures. We're at a place called Valhalla, spelled with a W, and it's the Walhalla Plateau, from here we get to see a package of rocks that we didn't really see well from Cape Royale. And it's the Grand Canyon Supergroup. It's this series of slightly tilted rocks in here down in the inner canyon. And about 1 billion plus or minus on either side. And it's sandstones and siltstones and some limestones, some basalt flows. There's some variety of units in there. This particular part we're looking at is called the Unkar Group. The Grand Canyon Supergroup has a couple groups in it, plus some miscellaneous other formations. And but here we're seeing the lower of those two groups in the Grand Canyon Supergroup. And this package of rocks was tilted during faulting and then beveled off by erosion, and then the Tapete sandstone, which forms the big cliff in the distance, bevels right across those rocks. So this is one example of what a lot of people call the Great Unconformity in the Grand Canyon. And the Unkar itself is in unconformable relationship on vertical standing metamorphic rocks. And so that's also part of the Great Unconformity. And where those two unconformities meet, that's the greatest unconformity. In that particular case, the rocks on top are 500 million and the rocks below are 1.7 billion. And so you're missing 1.2 billion years of time that's not recorded along that contact. A lot happened. Deposition of the Unkar group happened. Tilting of the Unkar group happened. So when you see an unconformity, it's not like nothing happened. It's just in that place, there's no record of what happened. This particular part of the Colorado River, which you can see down in the bottom, a lot of people call Furnace Flats because you don't have the big shady canyon walls close to you along the canyon. And so the sun really gets you. And so there's not much shade. And so if you camp there, like on a boating trip, it's a pretty hot place. There are a lot of Native American activities happen down in that place because it didn't have the big cliffs, so you had some places you could grow things. And so there's a lot of ancestral Native American culture associated with Furnace Flats. In the distance, you can see the south rim of the Grand Canyon, actually a place called Desert View. And you can't pick it out here, but it's there. And it looks like it's the same elevation as we are here, but it's actually lower than us. And so these rocks are tilted from us to them. And so that's why that south rim is lower than the north rim. It's really a function of the tilt of the rocks. The rock we're standing on, the Kaibab limestone, is a resistant rock. You strip away all the softer rocks off the top, both on the north rim and the south rim. And so it's the elevation of the Kaibab that's holding up the elevation of the rim of the canyon. We're now in Roosevelt Point, which is one of the easternmost viewpoints in the Grand Canyon. And this place is a really fun place from my perspective. One of the things you can see, we've got the canyon below us, and then in the distance you see this really nice plateau or platform back in there. It's capped by Kaibab limestone, which is what I'm standing on here. So one of the things you can immediately ask yourself is, why are we up here and why is that down there? And the answer is there's a very major fold in here, a monocline, where the monocline means it bends over once, then it flattens out again. The East Kaibab monocline is between us in here, and we'll point it out here in a second. But what that's done is uplifted this part of the Grand Canyon, the rocks of the Grand Canyon, versus those rocks there. So there's been a relative uplift between these two. With most structural geology, it's relative movements. We can't tell whether this went up, that went down. You know, they went up. There's a relative difference between them. And that's a beautiful wall. The Colorado River is just this side of that far wall and is flowing this way from left to right. The other thing you can see probably behind me, mostly blocked by my hat, is the canyon of the Little Colorado River comes in. And so most people talk about the Grand Canyon as this whole thing, but a lot of geologists would say from the confluence of the Little Colorado River to the main Colorado River, from that downstream is the Grand Canyon, and this is Marble Canyon up here. That was kind of the way John Wesley Powell used it. You can actually see that East Kaibab monocline. In fact, this is one of the best perspectives of it from within the canyon. There's a butte across this side of the Colorado River, And if you follow the red supai, reddish-brown supai at the base of it, it comes and it does this on this side of the butte. And then the other thing, the red wall limestone is below that, and it brings it up. So you actually see the red wrapping around that butte, but climbing it, and you see the red wall climb up around that butte. And that's the East Kaibab monocline. The layers are flat over there on the other side. They're nearly flat in most of the butte, and it comes up like this, and then flattens out again where we are. Another nice thing about Roosevelt Point, it provides a nice perspective on the Chuar, which is the upper of the two groups in the Grand Canyon supergroup. It's a late Precambrian rock. And you can see the Chuar, the tilted layers in here below all the flat-lying Paleozoic layers. So the Chuar is sloped like this, dipping 20 or so degrees, and then it's eroded and beveled off and overlain by that lower ledge, which is the Cambrian Tapete sandstone. So again, that's another example of the great unconformity in here between the Precambrian rocks, which are been deformed, and the Paleozoic rocks, which are mostly flat-lying, but of course in here there's the monocline as well. In the distance, that country is typically called the Painted Desert. So you have the Kaibab along this cliff face, and pretty much that marble platform, that's been stripped all the way down to the Kaibab. But as you start to climb the foothills on the back side of that, you start to see some more colorful rocks. Those are the Triassic rocks of the Triassic Moenkopi Formation and the Triassic Chinle Formation. The Chinle is the main unit that people talk about when they talk about the Painted Desert. It's the unit that hosts all the big petrified wood at Petrified Forest National Park, late Triassic in age. And it's reflecting the volcanism that was firing up along the west coast of North America. And so there was a lot of volcanic ash that got into that unit and got reworked and interacted with water and subsurface, mostly to make clays and things like that. And so that makes that kind of badlands, soft, fairly colorful kind of topography. In the far distance is a lump-shaped mountain that's called Navajo Mountain. There are a series of features on the Colorado Plateau called laccoliths, where you have layers and the magma comes up and it decides it's easier to squeeze the layers apart than it is to keep going. And so it takes something and does like that. It arches up the overlying layers and it makes these kind of lump-shaped mountains. And Navajo Mountain is one of them. There are a couple others around, and those are called laccoliths, L-A-C-C-O-L-I-T-H. On top of the Triassic rocks, there's a whole series of Jurassic rocks that make what's called the Echo Cliffs in here and the Vermilion Cliffs out of view. And those rocks are in here. And then there's another package of Middle Jurassic rocks, and then there's another package of Late Jurassic rocks, the Morrison. And then sitting on top of that is a whole sequence of Cretaceous rocks. All of those rocks were here, thousands of feet of them, and they've all been stripped off. So as this area, it was at sea level in Cretaceous time, got uplifted, you started eroding material off the top layer after layer, and some of those layers are really soft, they're shales and things, so they've been really easy to strip off. And then at some point, the erosion kind of hit this hard rock, the Kaibab, slowed down, except for the actual incision of the canyon. If you look out across this horizon, you realize that most of these are sedimentary rocks. Most sedimentary rocks are deposited in horizontal layers, and most of these layers are still flat. And so although a lot of these were deposited at sea level, like the Kaibab that caps that far cliff, these rocks have been uplifted and generally not had much done to them. They've pretty much just stayed flat, except for places where there are these other things like monoclines that fold them, or there's some other types of folds on the Colorado Plateau, or they get bowed up around the laccoliths. But overall, these rocks are pretty flat lying. They get some gentle dips, like there's this gentle dip between the north rim and the south rim, but it's pretty subtle. And, from a distance you can see it, but if you're standing on it, the rocks look pretty flat. We're at Point Imperial, which is the northeasternmost viewpoint in the north rim of the Grand Canyon. It provides a really nice view to the north. In the distance, you can see some reddish cliffs. That's the Vermilion Cliffs, which in that area surround the Paria Plateau. And most of the rocks in that cliff are Jurassic and Triassic. It includes the Glen Canyon group with the Navajo sandstone. It includes the Chinle Formation. It includes the Moenkopi. And then down on the platform, you're back into the Kaibab limestone, the Permian unit. Cut into the platform is the Marble Canyon, which is cut by the Grand Canyon. But in here, you're mostly just cutting from Kaibab down to about the Hermit or the Supai in that level. So it's a narrower canyon. It's not as deep, and the Colorado River is flowing this way. And then once it joins up with the Little Colorado, then we start calling it Grand Canyon. The Vermilion Cliffs go kind of back into that alcove, and then the same units come back out along what's called the Echo Cliffs. The Echo Cliffs is another monocline. The Kaibab limestone from the marble platform goes like this and does that. And so as it goes down, then you preserve higher rocks in the downfolded segment. And so you have, again, the Glen Canyon group rocks and the Chinle and the Moenkopi preserved along the Echo Cliffs, which is really between us and Page, Arizona. On behalf of McGraw-Hill and Julia Johnson, co-author of the Exploring series textbooks, Exploring Geology, Exploring Earth Science, and Exploring Physical Geography, we thank you for coming up here to the high country to see the geology of the North Rim of the Grand Canyon.